A trig substitution applies when we have the integrand in the form of square root of a square minus x square, or when we have the integrand in the form of a square plus x square, or the square root of that. In this case, we're going to use sign substitution. So we're going to substitute x equal to a sine of x, and then we're going to use this identity, which is cosine square of x plus sine square of x equal to 1. And then in this case, we're going to use tan substitution. So we're going to substitute x equal to a tan of x. And then we're going to use tan equal to sine over cosine, and then the identity of cosine square plus sine square equal to 1. First, we're going to simplify the integrand, and then we're going to simplify the integral, and then we're going to back substitute the function of x. Note in some cases we may need to complete the square of the integrand before we make the trig substitution. Now let's move on to our integral. Here we have the integral of the square root of 9 minus 4x squared dx. Notice this is similar to this term in here. Therefore, we're going to use trig substitution, and then we're going to use the sign substitution. But first, notice this x is alone, but this x has a multiple of 4. Therefore, the first step is to simplify this term in here. So I'm going to factor the 4 out. First, I'm going to take the integrand, which is square root of 9 minus 4x squared, and then I'm going to factor the 4 out. So 4, and then we have 9 over 4, and then minus x squared. Notice now the 4 can be out of the square root, so I'm going to have 2. Then we have square root of, and then for this term here, I'm going to write it in term of square. So we'll have 3 over 2, and then both squared, and then minus x squared. Now, this term is the same as this term, so I'm ready to make the substitution in here. First, I have to determine what is a. A here is just equal to 3 over 2. Therefore, x is going to be equal to a, which is 3 over 2, and then sine of theta. Now, let's find dx. So dx is going to be equal to 3 over 2, and then the derivative of sine of theta is just cosine of theta, and then d theta. Now let's make the substitution in the integrand first. So it's going to be equal to 2, and then square root of 3 over 2, all both squared, and then minus x squared is going to be just 3 over 2, and then sine of theta, both squared. This is going to be equal to 2 multiplied by the square root of 3 over 2 squared, and then I'm going to distribute squared to both terms in the second term. So I'm going to have 3 over 2 squared, and then sine squared of theta. Now notice this is a common term, so I'm going to factor that out. So we're going to have 2 multiplied by the square root of 3 over 2 squared. Then I'm going to factor that, so we're going to have 1, and then minus sine squared of theta. Now I can pull this out of the square root. So we're going to have 2 multiplied by 3 over 2. Then we have the square root of 1 minus sine squared of theta. Now note, this 2 will cancel with this 2. And then for this term, it's just going to be equal to cosine square from this identity in here. You just solve for cosine square. So this is going to be equal to 3. And then we have square root of cosine square of theta. This is going to be equal to 3 and then cosine of theta. Now, notice that we simplify the integrand from this here to this. Now, let's plug this back into the integral. So the integral is going to be equal to the square root. It's just going to be equal to 3 cosine of theta. And notice that dx is going to be equal to 3 over 2 cosine of theta d theta. Now we can simplify this more. First, I'm going to pull this constant out of the integral, and then I'm going to multiply this cosine by this cosine. So we're going to have 3 multiplied by 3, it's 9, and then over 2. Then we have the square root of cosine squared of theta d theta. Now we want to find the integral of cosine squared of theta d theta. To find this integral, we're going to go back to the table of integration. This is the table of integration. we're going to go to integer power of sine of x and cosine of x, and then we're going to use number 18 to find the integral of cosine square of x dx. So this is number 18. Notice n is equal to 2. So this integral here going to be equal to 9 over 2, and then the entire derivative of the integral going to be 1 over 2, and then cosine of 2 minus 1 of theta, since our variable here is theta, multiplied by sine of theta, and then plus 2 minus 1 over 2, and then we have the integral of cosine of 2 minus 2 of theta d theta, and plus our constant c. Now this is going to be equal to 9 over 2 multiplied by 1 over 2. Then we have cosine of theta, sine of theta, plus 1 over 2, and then we have the integral. Notice this power. This is 2 minus 2, which is going to be equal to 0. And then anything to the power of 0 is going to be equal to 1. So we have 1 and then d theta. So this is going to be equal to 9 over 2, and then we have 1 over 2 cosine of theta, sine of theta, plus 1 over 2, and then the antiderivative of 1 going to be equal to theta, and then plus the constant c. Notice in here we can factor the half out, so we're going to have 9 over 2 multiplied by half, and then cosine of theta, sine of theta, plus theta plus c. So this is going to be equal to 9 over 4, and then we have cosine of theta, sine of theta, plus theta, plus c. Now the last step is to back substitute cosine of theta, sine of theta, and theta, since our integral is in terms of x. Remember when we make the first substitution, we have x equal to 3 over 2 sine of theta. From here we can solve for theta and then sine of theta. So first let's solve for sine of theta. So sine of theta going to be equal to 2 over 3 multiplied by x. That's the sine of theta. And then from here I can solve for theta. I'm going to take sine inverse of theta, which is arc sine of theta. So that's going to be equal to theta equal to arc sine of 2x over 3. Now we want to solve for cosine of theta. To do that, we're going to use right triangle. This is our right triangle. I'm going to use sine of theta, so that's going to be 2x over 3. And remember, this is opposite over hypotenuse. This is theta, so the opposite going to be 2x, and the hypotenuse is going to be equal to 3. And remember that cosine of theta is adjacent over the hypotenuse. So we want to find the adjacent, which is this. So this I'm going to call adjacent equal to y. So it's going to be y over the hypotenuse. To find y, I'm going to use the Pythagorean theorem. So we have 2x squared plus y squared equal to 3 squared. That's going to be 4x squared plus y squared equal to 9. I'm going to solve for y. So y going to be equal to 9, and then I'm going to move the x term to the other side. So I'm going to have 4x squared, and then I'm going to take the square root. Therefore, y going to be equal to the square root of 9 minus 4x squared. Therefore, cosine of theta going to be equal to square root of 9 minus 4x squared over the hypotenuse, which is 3. Now let's go back. This is going to be equal to 9 over 4, and then cosine of theta going to be equal to square root of 9 minus 4x squared over 3 multiplied by sine of theta, which is 2 over 3 multiplied by x, and then plus theta, which is arc sine of 2x over 3, and plus the constant c. So this is going to be equal to 9 over 4, and then multiply by 2 over 9 multiplied by the square root of 9 minus 4x squared x plus arc sine of 2x over 3 plus c. Now we can multiply 9 over 4 into the bracket, so that's going to be equal to I'm going to have 9 over 4 multiplied by 2 over 9 of square root of 9 minus 4x squared multiplied by x plus 9 over 4 arc sine of 2x over 3 and then plus the constant. Now notice we can simplify this term. These lines will go together and this is going to be equal to 1 over 2. So this is going to be equal to 1 over 2x multiplied by square root of 9 minus 4x squared plus 9 over 4 multiplied by arc sine of 2x over 3 and then plus the constant. And that should be the antiderivative of the given integral using trig substitution.